Well, g'day, Max here again, welcome back to the shop. Well, this week we're going to continue on with the arbor for our lapping tool. Remember, we have the sleeve out of our LA Rochlau grinding attachment for our tool and cutter grinder. We have to take approximately half a thou out of the sleeve. Being as the sleeve is hardened, I think lapping's the only way to go with it. So last week we were rough turning it all. So it's had a week to sit, it's going to move and deal with all the stresses. It would have hopefully done it by now. So we will cut the 32 thread per inch, 1 inch thread for the adjuster, and there's a little parallel section to do on the end if we need to use a pilot at any stage. So we'll get cracking with that. Before we do that, we had a letter turn up in the post today in the USA from TN, Tennessee, I'm assuming. Now that's from Vern over at Mature Patriot. 2 Busted Thumbs Productions. So his channel's worth checking out. Subscribe if you haven't already. We all need a bit of motivation and to keep us ticking along, and that's what your subscriptions do. So Vern also sent us a business card. Now, as we'll find out shortly, this is what I like to do with business cards. They're handy when you're looking in the books, like a machinist book, when you're scrolling down through the tables, to use them as a line marker. So we'll get Vern's sticker up on the board and continue on with our shaft. Okay, I think we'll squeeze them in here next to Lance and Patrick and Bundy Bear and under Bruce and Emma. Make sure we're sort of in the middle. There we go. Okay, well, that's all of our journals roughed out. So what we'll do next, we'll break the setup down and we'll reset the shaft up in between centres with a drive dog. Then we'll finish the pilot diameter, the threading diameter. We'll thread the shaft. Then we'll offset the tailstock to do the taper. Okay, we have our shaft set up between centres. So we just have our ordinary setup there with our revolving centre going into the end of the shaft and our headstock end. We had to use our faceplate to drive the drive dog because we don't have what's called a drive plate specifically for a drive dog. But that works okay. So all we've done, we've put a nut and a bolt through one of the slots in the faceplate, so that'll come up against the lathe dog and drive the lathe dog. What we've also done is put a couple of nuts and a bolt and just played around with it up and down for a different position in the slot, just to offset the mass that we have out here, because it'll give you a slight vibration when you run the lathe. You'll feel it more noticeably when you turn the lathe off and it slows down. So that offsets all that mass there. So when we start her up, she's all running nice and smooth without any noticeable vibration. So we'll get a tool set up and we'll start on these 2 journals. Yeah. Okay, here's a quick look at our vertical shear tool that we're going to be using. So that sits in this position and now comes up against the workpiece like that. So you don't have to be right on centre, as long as your workpiece and your tool create a tangent in the front face. These are an amazing tool to get a really good finish on a piece of gnarly old mild steel bar, and they're quite as simple to grind. You've only got 2 grinds. So we look at the front of the tool. So that's just ground vertically up and down that way, but with a clearance angle approximately 10 degrees running back. Just it stops the rear of the tool from rubbing. So we have a very slight 10-degree angle back that way. And the other angle is, if you look at the front of the tool, where it does the shearing action, we have this angle just here, and that's approximately, like they're only approximates, 15, 20 degrees, whatever, and that will work. So there's only 2 angles to grind. It's quite simple. So just remember our 15, 20 degree angle there. And the 10 degree also clearance on the front face. So we'll get that set up and take a cut. Okay, that's our shear tool set up. So as you can see, it doesn't have to be too critical on centre, as we have a gap underneath. We have a gap on the top. So what we in effect have is the cutting area just here, running in tangent with the shaft. So looking from the top, it's a bit hard to see, it's hard to get a clear shot. We'll take a cut and you'll see the fuzz that comes off this. Take a couple, 1 or 2 thou maximum depth of cut with these tools. Looking at the chips, that's quite a heavy cut I'm doing there for a shear tool. The other one disadvantage is you can't go right up to the shoulder because of the angle of the cutting edge. So that's an absolute beautiful finish. Just here it's a bit chattery. I had to slow the lathe down a little bit. No, that's good. So I'll take a measurement and get long, these stringy things. That's a result of quite a big cut for a shear tool. The normal swarf you get off it's a bit like a steel pad, a steel wool. steel wool. So we've hit our target size, inch and 7/8 of an inch. We'll focus. No, camera doesn't want to focus today, but we're there. Okay, so now we'll do our 1 inch. But the shear tools are brilliant for taking that last half a thou off a job. Taking a colour in our second journal, that's going to chatter too. With such a light cut, we shouldn't have any problems with chatter, but we are. So let's see what options we can do to overcome it. One is it's possible wear in the bearings of the centre that's causing it. So we could swap our centre out with a centre that's not so worn, but this is the only one I have. Or we could try putting a dead centre in. That will eliminate any play in the centre. We'll try that first because we don't want to reduce our speed anymore, our RPM that we're cutting. So let's slip the centre out. We'll slip in a dead centre. I'm sure if you put an indicator on there you may pick some play up, so we'll slip him out. We have a, where are we? We have a dead centre here. We'll slip him in. Now because it is a dead centre, we'll just put a bit of grease. A little dab of grease on the end. And also a little dab of grease in the end there. We'll keep it as short as we can. Now we have to be very careful how much tension we apply, so we only want very light tension, otherwise it will overheat. We'll try that. And we're only taking a 1 thou depth of cut then, so we'll try again. Seems to be behaving itself now, but we're not taking a full cut, we're only taking a little bit of a high spot off the shaft. Now the reason why we have a high spot there is something, I'd say the shaft has probably relaxed a bit since we've taken so much material off the outside. So therefore we'll have a very slight warp in it. So that's the reason for rough machining the shaft and then coming back to a finished cut. Always pays to just touch the end with your fingers just to monitor the temperature. You don't want that getting too hot. It's only just very slightly warm, that, so that's still okay. We're still within a good range. Might have one more cut to do after this. Use the pliers. Too easy to put your fingers in there to grab the sharp and curly bits. So what we're going to be shooting for is about 2/1000ths of an inch below 1 inch. So 998 is what we're going for. So we've got 1 thou to come. So this will be our finishing cut. Okay, we are 3/10ths up on size. Actually 2/10ths up on size. So that'll be good. As I say, we're gonna thread, single point thread this 32 TPI. The fuzz off. So changing over to the old style dead center as opposed to the revolving center that we had has cured those chatter issues. So this sort of leads me to believe there could be a bit of play in these bearings. Okay, well, we'll get set up for screw cutting. One other point, because we're screw cutting between centres and we have our drive dog, if we don't notice this moving away from this at any point when we stop the lathe and restart it, this has a possibility that the lathe can start with a gap here. Now that will de-pitch your thread. So all I will do is just put a cable tie pull that up tight. Now that will secure the drive dog up against the driving peg there, so we can't de-pitch because that's moved location. Okay, so we're going to be cutting a 1-inch 32 TPI thread. So we look up the information in our Starrett book for student machinists. This book belonged to my father when he was an apprentice machinist at the Post and Telegraph workshops. So if we look up our double depth chart, we look to 32 TPI. We look under V threads, and it gives us a double depth of 0.05412. Now we're not worried about the others, the Whitworth, we're not cutting Whitworth, American National Form double depth. That's a lesser amount because that takes into reference the crest and root profiles of the thread, where the V thread depth is just a pure V. So that's why that depth is deeper. So the profile, which you would normally measure with a set of pitch gauges, would still be relatively the same. Okay, so our double depth is 0.05412. So 0.05412. So we halve that, and we get near enough to 0.27 thou, and that's our depth of cut. Okay, if you don't have any reference material and you have to cut the thread, so our 1-inch diameter 32 teeth per inch thread, you can use another method. So what you do is you 1 inch divide by 32. We'll do that on the calculator. So 1.0 divide 32. That gives you 0.03125. Now, with that you multiply by 0.866. Multiply by 0.866 will give you 0.02706. So we're still at 27 thou depth of cut. So that's just a different way to do it. Now the constant there that you multiply the pitch with, 0.866, that's derived from the cosine of 30 degrees. So that's another handy way, an easy, simple way to do it. Obviously the best method is, or for your final check, is with thread wire gauges, but mine are still in the post. I've never owned a set. Well, finally, I think it's about time I did own a set, so they're on their way. So we'll crack on with our thread. Okay, we'll mark the part up with a Sharpie. Then we'll take our scratch pass and check it with the pitch gauge. Oops. Just need to zero our tool. Now I think I'll probably need a magnifying glass to see that lot. So we line up our pitch gauge. Make sure we're on 32, which we are. And it appears we're cutting 32 teeth per inch, which is what we want. Now, this pitch gauge is Whitworth, but it doesn't matter. A thread per inch is a thread per inch, regardless if it's Whitworth or unified. So, we'll carry on.